Welcome to the completion of MC9. The suspense is killing me. What is this going to look like on a graph? As you can see from this table here, this is the work we completed on the first part of this video, which was using substitution of the x value into this equation, y equals 2x plus 5. That's how we got these y values. If you missed that part, go back and watch that video, because this time we're here to graph this. We have a completed table filled with x and y values. First, we need to organize these into ordered pairs, which, as you remember from earlier school days, that's a pair of two integers. First is an x value, next is a y value. So all we do is translate what's on the table into ordered pairs. 0 and 5, we take the x value first, then the y value that goes with it. 1 and 7, 2 and 9, 3 and 11, -1 and 3. See how we're still using these pairs from the table. -2 and 1, and finally -3, -1. There are the ordered pairs from the table. Now let's make a graph, and let's be sensible about this. Our greatest x value on either side is 3 and -3. And it looks like the y values go up pretty high, up to 11, but only down to -1. So we're going to put the x-axis down here, and we're going to make the y-axis go this way. Remember, we have the value 0, 0 is called the origin, and you should always start there when you're graphing these coordinate pairs. Alright, so let's start with 0 and 5. First I need to scale my axes to make this correct. For my y value to go up to 11, I'm going to count this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then my x-axis needs to go 1, 2, 3 positive, 1, 2, 3 negative. Everything I do will fit on this graph now. Always do that first. Make sure your graph is big enough to hold everything you're planning on graphing, or else you'll end up with a line that goes off the page. And we don't like you to write on the desks. Here we go. First ordered pair. 0, start at the origin. 0 means I don't go either way, right or left, but I do go up 5. 1, 2, 3, 4, 5. Make a nice dot there. Next, here's my finger pointing to the next one. 1 and 7. So I'm going +1 or to the right, and then I'm going up 7. About there. Sometimes if you have these big squares on your graph paper like I do, you have to use your estimating skills to figure out where each coordinate will go. Over 2 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I was going to do that, but I wasn't sure, so I counted. And now I see a pattern happening. Just like we saw a pattern on the table, that same pattern will show itself in the form of, ooh, if I connected these dots, it would make a straight line. Alright, this is a linear equation. If you're ever asked, what shape does this linear equation make? Well, if it's a linear equation, it's going to make a line. Look for the word line. It'll make a straight line. Next pair is 3 and 11. I'm going to go over 3 from the origin, 1, 2, 3, and up 11. 2, 4, 6, 8, 10, 11, right in the middle there. Looks like I still have my line. Check, 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 check. Just like a list. This is my to-do list. I have 3 more things. -1 means I start at the origin and go left. And then up 3. 1, 2, 3. Check that one off. Next, I have -2 and 1. Start at the origin. Go left 2. 1, 2. That's negative. And then up 1. Can you still see my line here? Even though we haven't connected the dots, you can tell that my work is correct here. That's one way of checking your work, is if I had a dot sticking out here somewhere, something's wrong, right? I would need to do some work, but that's not the case. Check that off. -3, start at the origin, go to the left 3, 1, 2, 3. and then down 1. See how that's negative 1, down 1. Put me right there. My dots look great. I'm going to grab a ruler. Ooh, there we go. Got the yellow twisty ruler. See? Twisty. Out of my desk. I'm going to connect the dots. Now to make this a line, remember a line goes forever in both directions. Now since we don't have a piece of paper that goes forever in both directions, we can't really do that. The symbols that we use to indicate that a line goes forever is we make it into an arrow on the end. Okay, that's a little long there. Get that off. So I've got my line. All my dots are accurate. They came straight from my table. I rewrote them as ordered pairs. I connected them. This is a linear equation, and this has what's called a positive slope, meaning it goes up from left to right. That's something we'll talk about more later on in the chapter and in our book, but I just wanted to throw that word out there now to get it in your head. All right, so we have positive slope, a line going forever in both directions as indicated by these arrows. That's a linear equation, and we are done. Nice work.